A transformer is a piece of equipment that changes the characteristics of electrical energy from one electric circuit to another using electrical induction or magnetism. The change is usually a reduction or increase in voltage, also known as step up or step down. You see, it is easier to transport a higher voltage of electricity longer distances than it is lower voltages. However, once the electricity is close to the equipment that's going to use it, sometimes referred to as the utilization equipment, it's safer and more effective to be a lower voltage. A transformer does not create electrical power, nor does it have any moving parts. It changes electrical power from one AC circuit to another through induction. In order to understand the advantages and uses of a transformer, let's first look at the basic transformer parts. There are 4 basic parts in a transformer. The input, or primary connections, where wires or conductors are attached. The output, or secondary connections, again where wires or conductors are attached. Windings, these are also known as primary and secondary coils. And the last part, the core. The core is a large metal piece that helps make the magnetism work. Basically, 2 magnetic coils, the primary and secondary coils, are made up of metal that is highly conductive, such as copper or aluminum. They share the same field and transfer the electricity from one to the other. The transformer core is used to provide a controlled path for the magnetism generated in the transformer by the current flowing through the coils. The coils are wrapped around the core, and the specific properties of the coils are dependent upon the amount of times they are wrapped around the core. These wraps are often referred to as turns. The relationship between the wraps around the core from one coil to the other coil is called a ratio. In other words, if a transformer has a 4-to-1 ratio, and you introduce 400 volts on one side, the primary side, you would in turn get 100 volts output on the secondary side. Does that make sense? Let's take a look at a basic building transformer. Here we see the incoming power, also known as the primary power, coming in on the left side and energizing the primary coil. Then, through magnetism, actually induction, the electricity is transferred to the output or secondary coil. Again, there are no moving parts in the transformer, but the electricity is flowing through all these parts when it's energized. The size of a transformer and its components depend on the amount of electricity that is being used by the circuit attached to it. Transformer sizes are normally classified by a kVA rating. kVA means how many thousand volt amps the transformer is capable of providing. We'll talk about that in greater detail later.